projects. In this video, we are going to explain about the project title, a Bitcoin transaction network, analytic method for future blockchain forensic investigation. Introduction. This project introduces a new method called BTN, Bitcoin Transaction Network, to analyze Bitcoin transactions. BTN utilizes innovative algorithms in cache memory to efficiently detect illegal payments, offering an improved approach compared to traditional methods. Traditional methods for identifying illegal payments in Bitcoin transactions faced efficiency challenges due to the massive volume of data, resulting in time-consuming processing. BTN aims to address this limitation by introducing a cache-based approach to expedite analysis and improve accuracy. The project leverages cache memory, which allows for faster data retrieval and analysis. This cache-based approach significantly speeds up the processing of Bitcoin transaction data, making it more efficient and effective in detecting illegal payments. The use of blockchain technology in Bitcoin transactions ensures secure and transparent record keeping. This enhances the integrity of transaction data, which is vital for effective forensic analysis. Blockchain's immutable ledger ensures the reliability and trustworthiness of transaction information, which is critical in forensic investigation. Objective. In this project, Petri nets, a mathematical modeling tool, are employed to create models for Bitcoin transactions. These models allow for a structured representation of the Bitcoin transaction network (BTN), aiding in the analysis of transaction data to track and detect illegal payments. Blockchain technology is utilized in the project to securely and transparently record Bitcoin transaction data. This enhances the integrity of the data, making it tamper-proof and reliable for forensic analysis. The blockchain's distributed and immutable ledger ensures the trustworthiness of transaction information. The project enhances the tracking of potentially unlawful financial activities by applying pattern matching rules. These rules are used to identify deposit and withdrawal transactions and flag addresses that exhibit suspicious characteristics or contain invalid or missing information. This helps in the detection and monitoring of potentially illegal payments within the Bitcoin network. Requirements. Hardware requirements of the project are processor of 5.5 and above, RAM of 8 GB and above, ROM of 25 GB and above. Software requirements of the project are Node.js, Python 3.7.0 version, and Visual Studio Community version. Methodology. To implement this project, we have utilized the following modules. The first module is Upload Blockchain Transaction. This module involves the process of uploading blockchain transaction data into the system. It's the initial step where transaction information from the Bitcoin network is acquired and made available for analysis. This data forms the foundation for the forensic investigation. Parse and build BTN Petrinet simulation. In this module, the uploaded blockchain transaction data is parsed and transformed into a Petrinet simulation specifically tailored to model the Bitcoin transaction network (BTN). Petrinets are mathematical models that help represent and analyze complex systems like Bitcoin transactions. The simulation built in this module provides a structured framework for further analysis. Run pattern matching rules algorithm. Once the Petrinet simulation is in place, the system runs a pattern matching rules algorithm. This algorithm is designed to scan the transaction data for specific patterns and characteristics that may indicate potentially unlawful financial activities. It identifies transactions or addresses that match these patterns, allowing for the detection and flagging of suspicious behavior. Withdraw transaction graph. This module deals with the visualization and analysis of withdrawal transactions within the Bitcoin network. It generates a graphical representation or graph that illustrates the flow and relationship among withdrawal transactions. This visual aid can be instrumental in identifying and understanding patterns related to withdrawals. Deposit transaction graph. Similar to the withdraw transaction graph module, this part of the project focuses on deposit transactions. It generates a visual representation of the deposit transactions in the Bitcoin network, helping investigators analyze the flow of funds and identify patterns associated with deposits. Blockchain integration. The project begins by leveraging a dataset sourced by Bitcoin blockchain. This dataset serves as the fundamental source of information for the analysis and detection of potentially suspicious activities within the Bitcoin transaction network (BTN). The blockchain dataset contains transaction records that are essential for forensic investigation. To model and understand blockchain transactions, the project uses PetriNets, a mathematical modeling tool. In this representation, addresses within the blockchain act as places, while transactions serve as transitions in the PetriNet structure. This approach allows for the accurate simulation of state changes and interactions within the Bitcoin network, providing a clear and structured view of transaction flow. Within the PetriNet model, the project employs pattern matching techniques to analyze blockchain transactions. This involves identifying transaction patterns and characteristics that may indicate potentially suspicious behavior. By distinguishing between deposit and withdrawal transactions and flagging suspected addresses based on these patterns, the project enhances its ability to detect and track unlawful financial activities within the Bitcoin network. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the dataset folder. To implement this project, we have utilized transactions dataset. Importing this dataset contains the information of timestamp, transaction ID, inputs, outputs, block ID, previous block, Merkle root, etc. This is the main code file. This is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the application. This is the graphical user interface created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload Blockchain Transaction button to upload transaction dataset. Select the transactions dataset and open. In above screen, dataset loaded. Now click on Parse and Build BTN PetriNet Simulation button to extract transaction address and build PetriNet object. In above screen, all transaction addresses extracted with time details. Now click on Run Pattern Matching Rules Algorithm button to detect illegal payment addresses by matching rules. In above screen, propose algorithm displaying suspected illegal payment address, and the processing time is this. Now click on Extension Rules Matching from Cache button to avoid already detected illegal payment addresses and scan only new transaction. In above screen, with extension cache, it took this much time. Now click on Withdraw Transaction Graph button to view all withdraw transactions from different accounts. This is the withdraw transaction graph. X-axis represents total withdraw from account 0 to 1 and vice versa, and y-axis represents number of gather addresses for that withdrawal. Now close this graph. Click on Deposit Transaction Graph button to view all deposited transactions from different accounts. This is the deposit transaction graph. X-axis represents number of account ID and y-axis represents number of deposit transactions made by that account. Now close this graph. Click on Propose versus Extension Graph button to get execution time graph. This is the execution time graph. X-axis represents technique name and y-axis represents execution time, and in above graph we can see extension cache technique took less execution time, so it's faster than propose algorithm. Now close this graph, and the conclusion of the project is utilizing PetriNets, the project efficiently models and simulates Bitcoin transactions. This mathematical framework offers a structured and clear representation of interactions between addresses and the changing states of transactions, providing a systematic view of the transaction network. The implementation of pattern matching rules is a key feature, enhancing the identification of suspicious transactions and addresses. These rules effectively differentiate between deposit and withdrawal transactions, aiding investigators in tracking potential illegal activities within the Bitcoin network. The project's methodology significantly improves the efficacy of forensic investigations in the Bitcoin network. By accurately pinpointing suspected addresses and transaction patterns, it enables authorities and analysts to concentrate their efforts on potentially unlawful financial activities, ultimately strengthening the security and trustworthiness of the blockchain ecosystem.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.